Yes, you do have a quiz tomorrow. Let's talk about why. So you might be thinking to yourself, Mr. P, what the heck, dude? Like, we just had a quiz. Like, how could we possibly take a quiz tomorrow? That's a great question. We took a quiz yesterday because we were supposed to take one Monday, but everyone skipped school. So, if it seems too soon, that's why. The other reason why is the quiz that I'm going to give you guys is short. So it's just going to be 3 questions. And you may be asking yourself, what have we learned in the past few days? Well, some of that we learned on Monday. So if you weren't here, go back and watch that video if you haven't already done so. But I will give you 3 questions, and I'll tell you what they are, okay? You'll have questions on finding, well, what did you guys do yesterday in 4.4? What did we learn?
Absolute min and max.
Yeah, so I'm going to give you some functions. You got to tell me absolute min and max, okay? What did we learn? We learned about a new type of test on Monday, and I know most of us weren't here. What type of test did we learn about on Monday? Do you remember? Yeah, second derivative test, but it allowed us to find extrema, right? So second derivative test will be on there. I'll give you a function. You have to perform the second derivative test to determine the relative extrema of that function. And then, like I said, finding absolute mins and maxes. Okay? All right. So it's going to be short. It'll be a 20-minute quiz. I'll do it at the end of the period. That way we can warm up our brains with section 4.5, which is a bit of a doozy, if I do say so myself. And then we will do that quiz at the end. Okay?
Are oblique asymptotes on it?
No. Do we feel we need more practice with oblique asymptotes? I heard there was a question about oblique asymptotes at the math competition yesterday. Is that true? Was there not? My kids in first period were talking about it. Maybe instead they were talking about number 49. Was there one about like absolute value of a trig function or something like that? Was there? Okay. Yeah, those are tough. We started working through number 49, but then we ran out of time. What we're going to do today is I'm going to roll through section 4.4 first because I want to make sure I get that stuff down. And then with whatever time we have left, we will go over the homework. They asked about 15. I didn't get to 15. I didn't even get to 49. I started talking about 49, and then we started talking about how the domain breaks down, and then we had to go to that assembly. So, all right, real quick recap. So we talked about absolute mins and maxes. We first talked about it on a graph, and we noticed that when we approached some graphical examples that were defined as a continuous function on a closed interval, we always had both an absolute max and an absolute min. However, when we looked at some examples that were on an open interval, we did not necessarily have an absolute max, or an absolute min, okay? Which led us to what was called the extreme value theorem, which told us that if we do have a continuous function on a closed interval, you're guaranteed to achieve a max at some point and a min at some point. The question is, where could those things occur? You've got 3 options for where you could have an absolute max or an absolute min, and they're on the board, right? First place is where your derivative is equal to 0. So we take our derivative, we set it equal to 0. That gives us our relative extrema, but you can have a relative extrema that's also an absolute extrema or a global extrema, right? So where your derivative is equal to 0, those x values are candidates. Where your derivative is undefined are also candidates as well too. But then apart from that, you need to remember to check the endpoints of your intervals as well, okay? So endpoints of your intervals, and then your critical numbers. That's where your candidates for your absolute mins or absolute maxes can occur, okay? And then we talked about if we're defined on an open interval, then we should take one-sided limits at each endpoints, because really what we're determining is, does that one-sided limit go down further than the candidates that we tested for relative extrema, or absolute extrema rather? And if we're operating on the entire real line, then we have to consider end behavior. So limit as x goes to positive or negative infinity, okay? All right, so we did this example. We did this one as well too. Let's kick it off with another simple-ish example. All right, so we have a cubic function, and we want to find our max and min values of that function on that interval, okay? So we should start by doing what? First derivative. So let's take our first derivative. All right. So 3x squared minus 6x minus 9. And then we factor that, right? We can factor 3 out. And fortunately, I can factor that again. So x minus 3, x plus 1 equals 0, gives me x values of 3 and negative 1. Okay? Those are candidates that I may or may not test in my interval. So now I've got 4 different intervals there, and I'm going to give you a fifth as well too here in a few minutes. But I have 4 different intervals here. The first one is the closed interval from -2 to 0. Okay? So what values do I need to test? Let's do them in numerical order. But what values do I need to test for that first interval?
-2.
Okay? What else?
-1.
And?
0.
No point in me testing 3 because it's outside of our interval. So we plug each one of those values into our function, and we see what we get. Oh, man. All right. So let's see. If I plug in -2, I don't really leave myself a lot of room to do this, eh? Calculator. Let's see. We would have -8, and then minus 2 squared is 4 times 3 is 12, so minus 12. And then plus 18 plus 11. 9 for the first one. If I plug in -1, we would have -1 minus 3, which is -4. -4 plus 9, which is 5. 5 plus 11, which is 16. And if I plug in 0, I get 11. Okay? All right, so then I would have an absolute max of what? What would be my absolute maximum value? 16. So that occurs at -116, but my absolute maximum value is 16. Okay? All right, and then my absolute min would be what? 9. So it's the lowest value that my function is going to attain on that interval. Okay? All right. Why did I put -0? I don't know. I don't know why I did it. But it's just 0. I don't know why I put -0. What do I need to test?
F.
Start with 0, right? Should we do -0? -0. That's ridiculous. F of 0. What else do I need to test? 3 and
4.
yeah, okay. All right, if I plug in -0, I get 11. Same thing as if I plug in +0. And then if I plug in 3, calculator, we would have 3 cubed. Actually, I think I can do this sans calculator. 3 cubed is 27, and then 3 squared is 9 times -3 is -27. So those values cancel out. And then minus 9 times 3, which is -27 again. So -27 plus 11 is -16. I'm not going to try plugging in 4. I can't do it. 4 cubed minus. Okay, 4 squared is 16 times 3 is 48. And then minus 9 times 4 is minus 36. And then plus 11. So my last value is -9. Okay. So then what I would do is I would find absolute min and absolute max. You guys good?
Yeah.
Okay. What's my absolute max? Absolute max of what? 11. Oz, are you okay?
Oh, yeah.
I was asking her a math question.
That's what I thought. What would be your absolute min?
-16.
-16. I believe that it was math. I just want to make sure that you understood and you're not. Because I know you weren't here yesterday, Oscar, so I just want to make sure you weren't lost in it. All right. What do I test from 0 to 1?
0.
Ooh, okay, that's nice. All right, if I plug in 0, I get 11. Did I plug in 1 yet? No. So 1 minus 3 is -2. -2 minus 9 is -11. -11 plus 11 is 0. So even on that small interval, I still have an absolute max of 11. and an absolute min of 0. All right, things change a little bit now that I have an open interval from -2 to 6. Okay, what do I need to consider when I test my endpoints? One-sided limits. Because my function's not going to be, on this interval, I'm not going to include my output at -2, and I'm not going to include my output at 6. Now, fortunately, since I'm working with a polynomial here, it's pretty easy to take those limits. All right, so then I need to test, I need to take the limit as x goes to -2 from the right of f of x. I need to figure out what that is. I need to test f of -1. I need to test f of 3. And then I need to take the limit as x goes to 6 from the left of f of x. And then I can make my determination for our mins and maxes. Okay? Now, it's open interval at -2. So if I take the limit as x goes to -2 from the right, again, fortunately, since I have a polynomial, I just have to plug in -2, right? That's all I would need to do to find what that limit is, okay? And if you plug in -2, we already have that answer. It's 9 from before, right? The first interval had a -2 in it. So that, I know where that's at. And then f of -1, I have that value already too. It's 16. Cool. 3, I have that value. It's -16. And then f, as x approaches 6 from the left of f of x, I don't think I have that one yet. So calculator. All right, so 6 into my original function. So 6 cubed minus 3 times 36. And then minus 9 times 6, so minus 54 plus 11. So I get 65. Okay. In light of that, I need to find my absolute max and absolute min. What would my absolute max be?
None.
I hear 65. I hear none. It's not 16. It is none. Why is it none? Right. I want it to be 65. That's the logical choice. However, I have an open interval, so I don't actually take that value of 65. Well, what if, can I just do like 64.9? No, why not?
It doesn't match up.
Yeah, I could just do like 64.99. Well, then let's do that. Oh, we could just pick it closer and closer and closer and closer, right? So the problem is we're trying to get to the ceiling, which we don't actually reach. So we would say that we have no absolute max. Okay. All right. Do we have an absolute min?
Yeah.
You bet your bottom dollar we do. What is it?
-16.
All right, very good. Okay, one more. I'm going to add the interval of -infinity to positive infinity. The entire real line. Well, then what else do we need to consider? Yeah, so really I got to consider my limits, right? My limit is x goes to infinity, and my limit is x goes to -infinity. Okay, graph dance, here we go. How do I figure out the end behavior of this polynomial? What does it depend upon? Highest degree, leading coefficient. My degree is 3, which is odd, and I have a positive leading coefficient. So with your arms, like you're hitting the graph dance at homecoming, what's that look like? Yeah, something like that, right? So what's my absolute min? Doesn't have one. What about my absolute max? Doesn't have one because it goes to infinity in either direction. I should say it goes to -infinity to the left. To the right, it goes to a positive infinity. So no absolute min or max. Do you guys see that I made an assignment on Google Classroom for you guys to put your homecoming graph dance videos?
Submitted some.
Did you? I haven't looked yet.
submitted one.
I didn't upset
I submitted the one with you in
the
it.
Gillette
And
yet, but-
Momchi.
Oh, how did you get the video?
I asked Lucy to send it to me.
Are they all?
Could you just look at who's in the video and give us?
Yeah.
extra
Well,
credit?
so that was my next question. You don't have to submit the same one. Will I be able to distinctly tell? Like, is it like
It
the video
starts
bright
off-
enough?
It starts off with only a few of us, but then it gets larger, and it's also only looks at us, but trust the entire band was doing it.
Yeah,
They
Well, I don't know who's in the band.
Ask Angie. Yeah. Or-
Camardo.
Nobody else can tell.
Come into the band room fifth period, and we'll tell you about our graphic.
Girl,
Okay, but we got Mrs. Gillette, and you can clearly see Mrs. Gillette, and I think that.
So what, Mr. Logan's extra credit?
I think we should get extra credit for Mrs. Gillette.
extra credit?
Like extra.
Oh my god.
We had to convince Mrs. Gillette, me and Natasha.
It could not have taken that much effort. It could not have taken that much effort.
We were standing there for she was like, she wasn't about to do it.
Oh, yeah.
Oh yeah, the music video. That's right.
This weekend I have the SAT and then
I work summer.
I work summer. Okay, you guys can do it at Cracker Barrel.
Yeah, everybody come to Cracker Barrel.
I'm not in a rush.
Okay, guys, example 4 now.
All right, example 4 now. We want to find min and max on still an open interval in this case. So similar to the last one that we just did, another polynomial. Let's find our end behavior first, kind of see what we're getting ourselves into before we launch into the derivative. So same thing. Depends on degree and leading coefficient. What's my degree? 4. So even. And then my leading coefficient is, yeah, but it's positive, right? Which is what I care about. So with your arms, what does it look like if you have an even degree and a positive leading coefficient? Like this, right? You can think of it like a quadratic. The legs are because I don't want my iPad to fall.
Oh.
I'm not convinced that it wouldn't have otherwise. But yeah, it would be a, you know, kind of looks like, behaves the same way that a quadratic would, okay? All right. So in that case, I'm not going to have an absolute max. Would you guys agree? Because like I'm going to infinity from the left and to the right. It's possible for me to have an absolute min. So let's figure that out, okay? All right, so 12x cubed plus 12x squared. Factor out of 12x squared. And then x plus 1. I set it equal to 0. Okay. All right, so obviously I get x equals 0 and then x equals 1. So those are my candidates. My bad. Thank you. That would have been embarrassing. Already embarrassing. All right, so f of 0 and f of negative 1 are what I need to test. Okay, so if I plug this into my original, if I plug 0 in, I get 0. If I plug negative 1 in, I would get 3 minus 4. So I would actually get negative 1 as an output, yeah. All right, so in that case, what would be my, since I don't have an absolute max, what's my absolute min? Good.
Kira.
What'd you do, Kira?
My pencil broke.
Wah, wah.
It unclipped.
Now, how do I know that my function doesn't go lower than negative 1? Because like I'm kind of leaving it a little open-ended. I know that it goes higher than 0, right? Because it goes to infinity. How do I know it doesn't like, you know, go to negative 1, but then like go down further and then go up to infinity? I already found the values where the derivative equals 0, right? So if it would go down any further, wouldn't it have to turn around and go back up?
Yeah.
That would have been picked up with me doing the derivative, right? Because it would have produced that value. So that's how I know it doesn't go down any further. Okay? All right, super. All right, find a max and min values of f on our interval given. Ooh, okay. My back is not feeling good today. I don't know why. Concert, that's why. All right, so we got to take our derivative first, right? Okay, so let's do that. How do you want to approach this derivative? I did quotient rule last period. Are we cool with that? Yeah, okay. So low, x squared minus x, times d high. This is where it gets you. What's the derivative of the top? Yeah, some people just put 1, simple mistake. But yeah, your derivative of the top is 0, which is going to make the problem a lot easier if that's a 0. And then minus high d low, so minus 1 times x squared minus x over low squared. All right, so then if I simplify that, 0 for the first part, and then negative x squared. Oh, sorry, I messed up the derivative of the bottom. I never wrote that. Sorry. Do you guys see my mistake? Sorry. I should have done minus high d low, so it's not this. The derivative of the bottom is 2x minus 1. I apologize. Okay, so then in that case, my derivative is actually equal to negative 2x plus 1 over x squared minus x quantity squared. Good. All right, now I gotta set that equal to 0. Okay, if I set that equal to 0, well, here's something I need to consider. The top equals 0 would just be negative 2x plus 1 equals 0. That's no big deal. I get positive a half. Are you okay with that? Yeah. What about my bottom equal to 0? Where's that going to happen at? 0 and also at 1, right? So if I set x squared minus x equal to 0, factor an x out, you get that x equals 0 and x equals 1. What can you tell me about those values I just underlined? What are they? They are critical points. Let's compare them to our original function. They make our derivative discontinuous, right? 0 and 1. Do they make my original function discontinuous? They do. What are they? Not holes. Yeah, why aren't they holes? They don't cancel. Yeah, so they're asymptotes, okay? So I have vertical asymptotes. What does your graph do when it gets close to a vertical asymptote? Right. So it goes to positive or negative infinity. So because of that, we need to figure out which infinity it goes to. Because if I have one going to positive infinity and one going to negative infinity, am I going to have any absolute extrema? I'm not going to. So I need to figure out how my function behaves around those asymptotes to figure out if it's possible that I could have one of those, absolute mins or absolute maxes. Okay, so what that means is I need to take the limit as x goes to 0. Now, don't forget, our interval is from 0 to 1. So I need to take the limit as x goes to 0, and I only have to do it from one direction. Which direction should I do it from? Very good, because my interval tells me I have values that are defined to the right. All right, so we're going to have to figure that out. And then I also have to take the limit as x goes to 1 from the left, right? Or I should say left, correct? All right. Okay, so if I take the limit as x goes to 0 from the right, I know I'm going to go to infinity of some sort because it's going to be 1 over 0, which is going to give me infinity. I have to figure out if I'm going to positive or negative infinity, okay? All right, well, what do you think? If I plug in, you can do it either way. You can plug it into this form right here, or you could think about f of x like 1 over x times x minus 1. You can plug it into that form as well, too. Okay, either one is fine. But either way, what type of values am I going to get? Negative. And here's one of two ways you can look at it. If you plug in like a number to the right of 0, that would be a very small decimal, right? What happens when you square a very small decimal? Or what happens when you square a decimal less than 1 in general? Does it get bigger or smaller? Smaller, right? So you get a smaller value, and then you subtract off that original decimal, which would be bigger. So you're going to get negative values. So I know I'm going to go to negative infinity. Okay. What about as I go to 1 from the left? Isn't the same thing going to happen, right? Because I would plug in like 0.99, which is a decimal. If I square it, I get a number that's smaller than that. And then if I subtract off that value from it, it's still going to be negative. That original value from it, it's going to be negative. So I go to negative infinity. So am I going to have an absolute min? No. So no absolute min. My only option is to have an absolute max. And what value could that possibly happen at? 1/2, right? Good. Now, how could I figure out if 1/2 was behaving as an absolute max or an absolute min? What else is something I could do to make sure? Max?
Sign analysis.
You said what? Sign analysis, right? Which means like check for increase, decrease, right? Because if I want it to be, we said no absolute min, we're hoping we would have an absolute max at 1/2, and then whatever that value ends up being. But in order to figure that out, max is right. So if I do like 1/2 right here, and I test the sign of the derivative on either side, let's see what we get. In my derivative, my denominator is always going to be positive. If I plug in a number bigger than 1/2, so let's say like 1, for example, I would have -2 plus 1, which is going to give me negative values. And then if I plug in a small number smaller than 1/2, like 0, for example, I get positive values. Is that indicative of a relative min or a relative max? Max, I'm going from increasing to decreasing. So as a way to double check, I did some sign analysis, and I have an absolute max at 1/2. And then if I plug 1/2 back in, he would have 1 over, I'll just do it. So f of 1/2 is 1 over 1/2 squared minus 1/2. If you square 1/2, you get a 4th. So I'd have 1 over a 4th minus 1/2. Common denominator would give me a 4th minus 2/4, which is -1/4, and 1 over -1/4. Multiply top and bottom by -4, you would get an output of -4. So absolute max at 1/2 and then -4. Okay? So my absolute max value is -4. But okay, questions there? All right, 15 minutes, 3 examples. I believe we can do it. All right, find the maximum height of the paper airplane whose path is given as follows. Okay, so f of t equals an x component and a y component. So x equals t minus 3 sine of t, and y equals 4 minus 3 cosine of t. That's weird. We have a function for our x values, and we have a function for our y values. Here's why. If you throw a paper airplane, does it always go straight? No. Sometimes it like curves around, right? So like really what this is supposed to do is it's supposed to model a situation where like you throw a paper airplane and it might like do some of these like tumbles or something like that. Okay? So that's what that function's set up to do. All right? Now if I want to find the maximum height of our airplane, which component do I care about? Why? Do I care about my horizontal component at all? If we're in physics, we talk about like our vector. Do I care about that horizontal part at all? No, I just care about the vertical part because I want to know when that's going to be maximized. Okay, so what should I do to that vertical component? If I want to find the max of it, what should I do? Let's take the derivative. All right, derivative of 4 minus 3 cosine of t. You'd give me what? Oh, man, what's going on? What's the derivative of 4 minus 3 cosine of t?
3 sine.
Yeah, okay. Thanks, Kira. And then we have to...
Equal to 0.
Yeah, okay. Sorry. Do you guys just want me to talk? I like hearing you guys talk. That's why I like leave it open-ended. Me talking is boring. Divide both sides by 3. You get sine of t equals 0. When does sine equal 0? 0, pi, 2 pi, 3 pi, 4 pi, right? However, we are defined on the interval from t is in between 0 and 10. So I don't feel the need to like bust out k and be like k times pi. You know what I mean? I think we can step out some specific values. Which values are we looking at here? 0, pi, 2 pi, 3 pi? Yeah? What else? That's about it, right? But what is the other value that I need to test? Yeah. I gotta check the endpoints of the interval. So I gotta check 10 as well too. Okay. All right, so f of 0, f of pi, f of 2 pi, f of 3 pi, f of 10. Oh, man. All right. Where should I plug those numbers in?
The Y, like the original.
Yeah. The original in the y part, right? I don't really care what my horizontal distance is at this time. I just care about what my vertical distance is. Okay. All right. So I'm going to plug it into 4 minus 3 cosine of t. All right. Cosine of 0 is what?
1.
Okay. So then 4 minus 3 times 1 is just going to give me 1. What about pi? Cosine of pi is... Very good. So 4 minus 3 times negative 1 would give me what?
7.
Yeah. 2 pi? 1. 3 pi? 7. 10? I don't know. I don't know what cosine of 10 is. So I got to bust out my calculator. So 4 minus 3 cosine. We're in radians. Super 10. Cool. So like 6.5172. Okay. All right. So what is my maximum height? Good. 7. Then it'll give us a unit of measure. What unit of measure do you want to use? Feet, meters, horses? What do you think? Micrometers? 7. Can we do millimeters? 7 millimeters. There we go. Okay, let's do some graphical stuff, all right? All right, thus concludes the content that will be on your quiz tomorrow, okay? Absolute mins. Now, I'm not going to give you one like this, right? It's going to be more straightforward of absolute max, absolute min, okay? All right, and then second derivative test, so make sure you guys study that as well too, okay? What my plan is tomorrow is Thursday. I teach 4-5. Hopefully I do it in one day? Question mark? So that would be Thursday. And then Friday, we would then do our chapter review after that. I might be a bit ambitious, but my original plan was 4-5 tomorrow, chapter review Friday, test on Monday. But we'll see. We'll see what happens. 4-5 is a bit of a beast. So we'll just see how that goes. But, okay. All right. Now, let's look at some graphs. I stole this graph from Mrs. Gillette. You can tell it's her handwriting as opposed to mine. But I really like this exercise. So I'm like, yeah, I'm going to do this with these guys for sure. All right. So we got a graph, y equals f of x. Let's say this is a closed interval. So let's say it's defined on the interval from 0 to h. Let's answer all of these questions about our graph, okay? All right, first of all, where is my function increasing? Over what interval?
B to D.
B to D.
I to H.
Good. So B to D unioned with I to H. Very good. Where's it decreasing? 0 to B. Unioned with, you said D to I. Okay, that sounds good to me. Where is my graph concave up? Meaning it holds water. My graph would be above its tangent lines. You said what? So from A to C unioned with E to H. Do you guys agree with that? Seems right. Okay. What about concave down? 0 to A. Can't forget about that interval. And then C to E. Good. All right. So if that's the case, what are my inflection points? Good. Now, I can't actually write it as a point. I should say the numbers, right, of our inflection points. Because I didn't give you any y values, right? So let's just say x equals, you said A, C, and E. Okay. All right, same thing with relative mins and relative maxes. I can only give the x coordinates at which they occur. So give me a relative min. Or I'm sorry, we did maxes first. So where would my relative maxes occur at? Just D. I can't, yeah, any others? Just D, right? Okay. What about my relative mins? B and I. Okay, very good. All right, meaning my critical numbers would be what? B, D, and I. Good. I see no other values that I need to include. Okay, and then what would my absolute min be? Again, I can only say the x value at which it occurs, right? You said what? Yeah, it's kind of tough to tell, but let's say B. So at x equals B. All of these should be at. Okay. What about my absolute max? You said where? It's close. Yeah, it's close. So then 0. Sorry, Soph. All right, that wasn't too bad, right? Hey, let's do the same thing, but imagine that this is now the graph of our derivative. And we want to answer all of the same questions, except this is our derivative. That changes things. So normally, how would we find intervals of increase, decrease? What would we have to do? Derivative equal to 0, right? And where it's your derivative is either positive, it's increasing, and then where it's negative, it's decreasing. So if that's the case, and this is the graph of the derivative, we just have to interpret the graph differently, okay? Where would this derivative be positive? 0 to A. So that's where the graph of the original is increasing. So this graph is going to tell us different things, okay? So we would say from 0 to A, unioned with, do I have any other intervals of increase? Very good, because my derivative is positive from G to H. It's going to get tricky here in a minute. This is already kind of tricky. What about decreasing? Where's my derivative negative? I agree that it's A to G. However, I am going to split it up into two different intervals. Because when we talk about our derivative, like when where our function is decreasing, it is where f prime of x is less than 0. Not less than or equal to, but strictly less than 0. And we're going to assume that d is hitting that value right there. So we would say it is decreasing from A to D, unioned with D to G. Is everyone taking the quiz in this class? I think so. I started grading them, by the way. If you put it as one interval...
Azra.
Hi, Azra. If you put it as one interval, which some of you guys did for like increase, decrease, or whatever, that's fine. That's okay. So if you happen to have a problem where you had to put it as like two separate intervals or one interval, if you put it as one and didn't split it up, that's okay. Because I think that's how I taught you initially, but I'm kind of recanting that now. All right, concave up. Where is my graph going to be concave up? This part is tricky. It's where your slope of your tangent lines are going to be positive, right? So where your first derivative is increasing, that's where your second derivative would be positive. There's levels to this stuff. That's what makes it tricky. Okay, so where's my first derivative going to be positive? Or where's the slope of my tangent line, my rate of change, and my first derivative going to be positive?
B to D.
Okay. How do we feel about that? That's tricky stuff, dude. Like your rate of change is positive here. That's why, and since it's the rate of change of your first derivative, that would tell you the sign of your second derivative, okay? All right, where's it going to be concave down then? 0 to B, unioned with, where else is it going to be? D to I. Very good. It's hard stuff, man. That's tricky. So what are my inflection points? Do you guys agree with Kira? I agree with Kira. Okay. What about my relative maxes? Where do I have a relative max? That, again, that is where your derivative would go from positive to negative, right? Where's that happen at? Which one is it, 0 or A? A. Because the sign of your derivative is positive to the left of A, and then to the right of A, it's negative. So at x equals A would be a relative max. Any others? Nowhere else does it go from positive to negative. Okay, what about the flip side of that? Where's your derivative go from negative to positive? Good. Okay, bless you. Trick question. What's our critical numbers? Critical numbers. You said what? Good job, Jay. So A, D, and G. J threw D in there because my derivative is 0 there. However, it didn't end up being one of our extrema, but that's okay. We still need to include it in our critical numbers. Can I find my absolute min or absolute max? I can't, because I need to know the outputs, and there's no way for me to determine that yet. But eventually we can, just not yet. Okay. All right, your homework is day 2 here. I know you guys want to see 15, so we'll do that tomorrow. So we'll do a little bit of review tomorrow from our homework. I'll teach you guys 4-5, and then we'll take a quiz. I don't know, man. I just don't know if we'll do... I probably won't cover all of 4-5 in one day. So I think it's more likely that your tests will be Tuesday instead of Monday. So that's okay. That's all right.